Hello everyone, I'm presenter here. So before we start, I want to introduce myself. My name is Dinda Febriyanti, and my major is interior design from Universitas Sebelas Maret. So for this experiment, we call it Suitability Study of Disposable Mask Waste as an Acoustic Absorber Material. So for the introduction, it's about a mask. It's a spunball fabric, a type of non-woven or non-knit fabric made from the polypropylene. And spunball fabric are disposable masks and can be thrown away immediately. So therefore, our experiment with the mask as an acoustic material to finding out whether mask can be used as an acoustic material. So for the background literature, we use one of the reference from Indonesia. It's called Use of Mask Waste and Absorber Sound, which is written by Privera, Anwar, and Noviadi in 2023. It says that the thickness of the mask can be said to influence the effectiveness of the material. This test aims to measure the sound absorption coefficient at the thickness, which is namely 0.512 cm, and use frequencies of 250 Hz, 500, 1000, and 2000 Hz. And the result they got, which is 2 cm thickness, had a better ability to read the sound, namely 0.37 at frequency of 2000 Hz. So for the method we use for our experiment, which is tube method, which is measure the sound absorption coefficient as well as determine the characteristic of the acoustic properties of material. So if, as you can see the picture, the test tube in the middle, and then you can see the sample for the color is blue, and then the microphone is the red one, and then if you can see the sound source in the left side. So for the result, is the result from the graphic. As you can see, a graphic in the right side, and then it's include only the important of the result. So in the table 1 is absorption coefficient testing system for the black mask and the pitch mask, which is we just only use 2 masks on this experiment. So for the discussion, the frequency result of 400 Hz, which is 0.70 from the pitch mask and 0.48 for the black mask, which is have made the minimum limit as a sound absorbing material. So however, at 600 Hz frequency has a very drastic decrease, which is 0.28 for the pitch mask and 0.25 for the black mask, and is not suitable because the absorption coefficient value is still low, and that's why it's only suitable for the frequency of 400 Hz because the absorption coefficient value is above 0.3. So the conclusion here, we use one of the reference too. So it's from Duele, it's 1993. It said that in accordance with the absorption coefficient value that must be met, namely at least 0.3. So the result of the 200 Hz frequency sample variation were said to be ineffective at reducing sound, and the highest one, which is the frequency of 400 Hz, which can be categorized as acoustic absorber panels or sound absorbers. So if we connect it to the background literature, so it's about the thickness. So the black mask require 50 masks, and the pitch mask require 27 masks to have the thickness of 2.5 cm, which is greatly influenced by its thickness. So and that is the quality of the pitch mask is better than the black one, and it's more stable, which is above 0.3 or 0.30, even though it's decreased on 600 Hz, namely 0.28, which is under 0.30. So this is the last one, which is the reference that we use in our literature, and that's the result of our experiment, and thank you.